The universe is vast. It's everything we can touch, see, sense, measure, or detect. It includes all the stars, planets, galaxies, and even time itself. Scientists believe that the universe started from a single point, smaller than an atom, about 13.8 billion years ago. Everything we know was once crammed into an incredibly tiny space. So how did we get from a tiny dot to a universe so big we can't even see the edges? That's where the Big Bang Theory comes in. This theory is our best explanation for how the universe began and evolved into what we see today. Buckle up, because we're about to take a crash course in cosmology. Let's dive in. The Big Bang wasn't your typical explosion. It was the expansion of space itself. Imagine a tiny balloon suddenly inflating to an enormous size. In the first fraction of a second, the universe was incredibly hot and dense. But as it expanded, it cooled down, and things started to form. First came elementary particles, then protons and neutrons, and eventually atoms. These atoms later clumped together to form stars, galaxies, and everything else we see today. The Big Bang Theory is supported by evidence like the red shift of distant galaxies and the cosmic microwave background radiation. It's a good reminder that even though we've come a long way in understanding the universe, there's still so much more to discover. Now let's talk about galaxies. These are massive collections of stars, gas, dust, and planets, all held together by gravity. Our galaxy, the Milky Way, is just one of billions in the observable universe. Galaxies come in different shapes and sizes. Some are spiral galaxies, like our own Milky Way, with graceful arms swirling around a central bulge. Others are elliptical galaxies, which are more rounded and less structured. And then there are irregular galaxies, which are, well, kind of all over the place. Inside galaxies, stars are born, live out their lives, and eventually die. Some stars end their lives in spectacular explosions called supernovas, which can outshine entire galaxies for a short time. Galaxies interact with each other through gravity, sometimes colliding and merging to form even larger galaxies. If we zoom out even further, we start to see that galaxies aren't randomly scattered throughout the universe. Instead, they're arranged in a vast cosmic web of filaments and voids. The filaments are long, thin strands of galaxies, while the voids are relatively empty regions between them. This web-like structure is thought to have formed due to the gravitational pull of dark matter, a mysterious substance that we can't see, but which makes up a large chunk of the universe's mass. Studying the cosmic web helps us to learn more about the history and evolution of the universe. It also gives us clues about the nature of dark matter and dark energy, two of the biggest mysteries in modern cosmology. Here's where things get really weird. The atoms that make up everything we can see, stars, planets, you, me, only account for about 5% of the universe's total mass and energy. The rest is made up of stuff we can't see or interact with directly: dark matter and dark energy. Dark matter is like the invisible glue that holds galaxies and galaxy clusters together. We know it's there because of its gravitational effects on visible matter, but we don't know what it's made of. Dark energy is even more bizarre. It's a mysterious force that's causing the expansion of the universe to accelerate. We have no idea what dark energy is or where it comes from. Dark matter and dark energy remind us that we still have a lot to learn about the universe. So, what's next for the universe? Will it keep expanding forever, or will it eventually collapse back in on itself in a big crunch? If gravity wins, the universe could stop expanding and start contracting, leading to the big crunch. But if dark energy wins, the universe will continue to expand forever, getting colder and darker over time. Eventually, stars would run out of fuel and die, leaving behind a vast and empty cosmos. There are other theories about the fate of the universe, including the Big Rip and the Big Freeze. The ultimate fate of the universe is still unknown. One thing's for sure, it's an exciting time to be studying cosmology.